Hello, everyone. My name is Mohanty. I'm a dreamy-eyed PhD student at EPFL, and much of this talk will be a little bit about my research and a lot of my own rants. So, and for definitions, this was a small project, academic project I started at the beginning of my PhD. Recently, we got a little bit more serious and established it as a financially independent entity. But much of my talk here will be about artificial intelligence, in which I basically do my own research. So one question that is an easy one is, and a lot of you ask yourselves, is what can you do with artificial intelligence? And in context of this talk, as in many people would try to focus on that, but good for us that the media has done a really good job at convincing us on what we can do with artificial intelligence. If you want to figure out what people are dancing, how they are dancing, if they're talking or if they're not talking, you can do that. I guess I'm blocking people's views. Or if you want to detect plant diseases by looking at images of plant leaves, you can also do that. Or some of us are artists, and if you want to use artificial intelligence as a medium of expression and create your own art, you can also do that. Or if you really like games, not just one game, dozens of games, you can train models which can play all of these games probably better than you. Or if we add a humanitarian aspect to it, can we use satellite imagery to, artificial intelligence to understand satellite imagery, help organizations who are working in disaster areas to have faster responses and many other such things? We can do that. Or you take it a notch higher and use satellite artificial intelligence to simply generate the satellite imagery. Like in this case, these are all generated satellite imagery, 1 pixel at a time. But when you see a lot of these examples in the media over and over again, you always ask how. And that's one question for which many people do not have an answer to. The popular perception is it's one nerd in front of a whiteboard doing a lot of ugly maths and then finally coming up with something magical. But this perception is not something which is shared by just a handful, but it's actually shared by a much larger community of engineers and developers. And right now, many studies show that right now we only have about 300,000 AI engineers and researchers worldwide, when we really need millions. And this is also a very optimistic and exaggerated number, that you have 300,000 engineers, and which is sad, especially when we have so many optimistic journalists and so many optimists around who say, how much can we do, along with some good results of what we can actually achieve. But let's hold on to this thought here, and we'll get back to that. First, we talk about Bob. So Bob is a simulated skeleton which came out of my own research in the beginning of my PhD. And the thing about Bob is it's a simulated skeleton which lives in a simulated environment. And your job is to act like a puppeteer. Every 10 milliseconds, you send signals to all the muscles in the lower part of the body of Bob. And your goal is to figure out how to make Bob walk. So you have to be a master puppeteer to coordinate all these signals to the lower part of the body of Bob so that it figures out how to lift the legs, figure out how to pull off the balance and everything else. And this is a very hard problem. When I proposed this to work on this at the beginning of my PhD, in our community of something called as reinforcement learning, much of the researchers were like, this is too hard just because of the overall space in which we have to kind of operate. But anyway, we nevertheless started working on it. In the beginning, when you start kind of working on this problem, you see, all right, it's kind of trying to do something, taking a step, figuring out it messed up, but nothing much. A little bit deeper into the training, you see, all right, it's making some progress. Over time, it has figured out how to take that second step. After that, maintaining the balance is another story. In fact, this was in the early phases of training when a lot of people were working on us. It learns how to basically take the first step, figures out I'm losing my balance, then there's no way I can make it. It figures out how to do a perfect dive because its objective was to cover as much distance as it can. And I don't even know how to swim, but Bob figured out how to make that perfect dive. To move on, if you go deeper in training and spend a lot more effort and you throw a lot of ideas and compute, then you actually see Bob figuring out how to kind of walk. But it doesn't look like how we humans walk. Like, it's kind of jumping like this. But we realized what we were doing wrong was we were not penalizing Bob for the energy Bob was using in all the muscles. So it was very much like Superman. So if Superman existed, it would always be hopping like this because that's the optimal policy you learn. But accounting for all of this, you actually see that it learns interesting human-like policies. And actually, if you look at many other such things which were learned, you see it has very human-like gaits also at running. And in fact, some of these models are running at about 4.5 meters per second, which qualifies use for the Boston Marathon. So if Bob went for the qualifiers, he would qualify. But the interesting bit is, from the beginning, when I initially pitched the problem during the beginning of my PhD, and everyone was like, too hard a problem, and I started working on it. At the same time, I was also a little bit idealistic among some things in terms of my stance on reproducibility, my stance on open source and open science. So when I started working on this problem, I started this small project called as Crowd AI, and this was at EPFL, where the idea was any research problems we work on, we just put it up out there. We write a lot of documentation telling how exactly can you work on this problem. And we also give you a leaderboard where anyone around the world, does not matter if he's from a big university or a small university, if someone is a researcher or not, if anyone is curious and he thinks or she thinks has a better solution than what we claim in the paper, they can send us their code in a nice packaged way, and we actually run it. We train it ourselves, and finally we have a leaderboard of all the top results. And this way, we had about 500 participants in context of this particular competition that we held, who came together from all around the world to try to help teach how to make Bob walk. And this was interesting because a majority of these people on the top, they were not our classic sense of researchers. Because again, in our academic community of AI research, you go in there, there's only a handful of top conferences where you definitely have to be there to present your results. And it's just same handful of people who would present their results. You would hang out, have your beers, share ideas, have new collaborations, and the whole thing goes on and on. But in this case, it was interesting because suddenly we had a lot of new people, new faces. These were engineers who were just curious about what is this thing, how do we make this skeleton walk? And previously, while they would shy away from this because they thought I would need that whiteboard and a lot of ugly maths, but we actually spent a lot of time to ensure that anyone can work on this problem. We actually sat down and explained every bit of the basic premise of the problem, how to approach something like this, along with some other results, and along with our own code on how to do that. And this suddenly incentivized 500 people to come and work on a problem like this. And not only that, we got a lot of feedback. Some of it was interesting because here, this guy, he was not high up on the leaderboard where he didn't have one of those top solutions. But he said, in context of this competition, I was actually motivated to learn these basic tools, which basically introduced me to a completely new window of things I can do. And in general, in context of this problem, this community of 550 people who came in together to help this, they were amazing, and that was one of the reasons why we managed to solve this problem so fast and so well. And to come back to this example, this initial idea that these large group of engineers had, that I need to know this much of ugly maths to be able to do anything, was completely wrong. And to get back to this whole point, the pool of talent and engineers who lie in this, the larger group of developers out there, they are way more than just millions. And right now, we are still stuck with just 300,000 of researchers and grad students who are forced to work on this. The reason for that is something which has been haunting academia in different forms, and more so in this particular field of artificial intelligence. And this is where a part of my rant begins. This is around the elitism of expertise, which we basically very badly suffer from in academia right now. And the notion of elitism of expertise is, we are experts, that's why we are elite, and that's because we understand ugly maths, and you do not. We add a sprinkle of mysticism where we do not explain how this happens, but we have really beautiful results which the media brags about. And this helps us swell up our own value of our work and also our own value. and add to the mix a massive gap of demand and supply and impatient corporations on their race to be at the top of this AI race. And then there's a lot of money. And this whole thing is basically reinforcing this whole loop where a small group of researchers do not have any incentives to actually open up doors to a much larger group of engineers who can come in and fix this, come in and contribute and help us do our work a lot better. To give a parallel example, if you think about web development, right, how to build a website, if that was an elite skill practiced by a handful of people and very mysteriously, where would the web be today? Would we be celebrating 30 years of web in such a grand way just a few weeks ago? But as a matter of fact, in the early 1990s, it exactly was. Only a handful of people knew what HTML, CSS was, and these guys were the stars at that point of time. But a few good things were done right after that. That's why it's such a democratized field right now where everyone feels like they're a part of the web. We feel that the web is ours. And if you think about many other such examples, operating systems, browsers, right now much of the whole technological industry relies on Unix, different flavors of Unix. And to think about the amount of skills needed to write your own operating system, you would think it's a kind of a set of expert skills which are needed even today. But back in 1990, some people actually spent a lot of sleepless nights to ensure that these set of skills were open and accessible to a much larger group of people. That's why we have Linux today. The same for browsers, Chrome, Firefox. All of these are the same examples. The same thing can actually be done in context of artificial intelligence, and it needs to be done in context of artificial intelligence. So the question we need to ask ourselves is, what will it take to train 1 million engineers to develop state-of-art artificial intelligence tools? Where if you read about this amazing thing that your local newspaper talked about, another use of AI, you know it's your nephew who can just build it over a matter of few hours. And how do we get to that? So for now, in context of this small idealistic project I started at the beginning of my PhD, our approach has been, we first break down the myth that this is not the case. Like in case of Bob, we spent a lot of effort to convince these people that you can also do this. It's not something for which you need a lot of advanced courses and those 3 extra courses on probability and linear algebra. The second, we convinced them this. Then the second important thing is to make the tools and ideas accessible. Before you learn anything new at all, you need to get a hang of these basic set of tools, and that needs a little bit of investment. And sadly, in our case, many of these tools and ideas are still not very well accessible, even for many people in our community. So we put in a lot of our effort to ensure that these basic tools, ideas, explanations of problems, basic primitives upon which you build are easy and accessible in a set of places where anyone can build up on top of it. And finally, we make it a point to celebrate every success or incentivize a lot of these people. Imagine a small developer in India, and this guy who has been fiddling around with some web development, a little bit of kernel hacking, and a little bit of artificial intelligence now, will he ever think that I can write a paper which gets published in this, let's say, NeurIPS, which is like the biggest conference in artificial intelligence research? And even if it's not just a random Indian engineer, but I'm talking about an Indian PhD student in India, the overall number of steps and hoops that you have to jump through before you can even consider the probability that I will have a paper of my own in a premier location like this is actually way more than you can imagine. And in our case, we actually try to short-circuit that whole series of hoops, where given that in our platform, we have a lot of really good researchers, and when I have been talking about this elitism of expertise, I have been exaggerating a little bit, because a lot of our researchers are actively trying to fix this problem. And these are the guys who help us in kind of celebrating the success of many of these people by enabling them have academic footprints for all the effort that they put in, or giving away travel grants, prizes, flying them into wherever we are having a conference, and helping them become a part of this small community of researchers, and hopefully also growing this community of researchers. And also saying thanks and congratulations to all these people incentivizes them a lot more to put in this very few hours to kind of help us do better, do our own research a lot better. And in general, the overall ambition with these set of things are we want to be the largest community of AI researchers and practitioners. Right now, the largest community of AI researchers and practitioners is just one conference, which is a sad state to be. But can we make it millions and millions of developers and engineers who feel like they're part of this community? Then be the largest repository of AI tools and models. Another secret that I forgot to mention while I was telling you about these notion of having crowdsourced competitions was in all these competitions, participants, they come in and they submit their code and to be evaluated automatically. And in the process, they are actually packaging their code, ideas, everything in a neat way, so that any other PhD student like me who has to try to replicate their work, he does not have to spend that 3 initial weeks just trying to understand everything and get it to run. He can just click a button now, and then suddenly the whole thing runs and replicates exactly as I promised in my paper. So this also helps our community of researchers a lot more. And in the process, actually, when we started collecting these code and models, over a period of 8 to 10 months, we had collected a terabyte of user-submitted code and models. And when I actually saw that, all right, we are reaching a terabyte, then my mind was blown. That was not something I had ever expected. And then finally, the overall broad picture is, can we replicate the whole open source movement for artificial intelligence? And this is not hard, as easy as it sounds. There are many things that have to be done right, and where we have to address a lot of human elements, elements of opportunities, elements of access to compute. But again, we have to start somewhere, and this is where we started, and we are taking one step at a time. Finally, in this whole process, right now in our community, people are doing stuff like they're teaching agents to play Doom. Sounds silly, but then if you can teach an agent which can autonomously look at images of frames and figure out how to go in and not so violently kill other agents, then these agents learn the notion of competition in some sense. Then in a more generalized task, this is again a group at Microsoft Research. They came in with an interesting idea. Can we train agents which can do a variety of tasks inside Minecraft? This teaches agents on how can we basically learn generalizable tasks, where the only thing my model knows is not just to pick up a ball from the ground, but it also knows many other things. It can cook curry, noodles, and many other such things at the same time. Then more interesting, problems which are closer to state of our research are something with Google Brain, where can we teach these agents on how to hack other agents. So in the current times of deep learning and artificial intelligence, hacking your self-driving car would only mean pasting a sticker on the stop sign, which confuses a self-driving car to think that it's not a stop sign, but it means just go as fast as you can. So in those cases, can we add a little bit of noise to this image to kind of confuse the models to think that it's not a panda but something else? And their participants were divided themselves into teams. One group was trying to come up with robust models, which simply cannot be hacked. And another group were trying to hack the other group of people. In this gamified setup, at the end of it, we came up with really interesting theoretical, novel theoretical ideas which can help shape our future efforts in this field. Then much closer to home, organizations like the United Nations Library put out these large, interesting data sets from the League of Nations, where participants were trying to figure out how do we digitize them, or figure out where do these documents belong, or understanding satellite imagery, so that organizations like Humanity and Inclusion, Humanity and Inclusion can understand the satellite imagery for disaster responses. Or our very own SPB, which came in, and it was one of the most successful challenges, where they said, can we optimize the train schedules a lot more? And we do this a lot more. And then finally, if we do this right, we can together build the largest repository of reproducible solutions for many problems we care about, so that the next time we see about this amazing thing that some journalist in the media talks about, you know your nephew can replicate it by the click of a button. And these are a lot of collaborators who help with a lot of this stuff. Thank you so much. Yeah.
I'd like to ask you a question while Jenna is getting prepared for the showcasing. I hope I'm in the right order. But so, collective intelligence is something amazing. I got my PhD studying that. So we're not going to go much into the technical details of what collective intelligence is, but basically it's really like, in some ways, like lottery. You get to have like people propose some solutions, and these solutions are going to, most of them, they are never going to work, especially in open source. You get like tons of repositories that are just not working. But there is this idea that because you get so many different people with so many different perspectives, at the end, there will be something that is going to come out this. And usually also these ideas combine in a way that we call combinatorial, in a way that actually, in the end, some solutions that might not work by themselves, when you combine them, they're going to work together. So do you really think that what is your opinion about the fact that you're counting on the lottery to make AI go a big step ahead?
Yeah, no, I have a very strong opinion on that. And we did think about it. And in fact, one of the good things was we were very under-resourced in the beginning when we were getting started. But that meant us to come up with ways in which we can verify these solutions in an automatic way. So whenever you are submitting this piece of code or an AI model, we have to automatically run it anyway. It gets automatically evaluated and gets compared against all the other previously submitted model. So basically, we are indexing all these models as they come in. So when you come to have a look at this problem, you know that this is the order of performance of all these models on all these metrics. So you already have a good stat, and you know that by the click of a button, it deterministically will work because it was packaged by the participants for automatic evaluation. The second bit is on this notion of lottery, which I disagree. So again, in many of these collective intelligence tasks, it very much depends on how you design the task itself and how you facilitate collaboration between all these people. If you have incentives in place which incentivize these people to collaborate together, then these ideas, they basically crystallize together into this large mass of something which is a lot better. So it's, it's very much like evolution if you think about it. The fact that we are this human being which is so magically works together is not a lottery, even if it's just a lot of accumulation of probability over times where all the good things keep coming together. That's the same idea here.
Thank you, Mohanty. We'll continue discussion later. Yep.